Thank you, class, for watching. As usual, my usual disclaimer is that you have to have completed this before you continue watching the rest of this video. So for the first example, again, the key idea is that we want to get the opposite variables, the opposite coefficient of these things. So on the first one, what I'm going to do is I'm going to multiply the two equations and eliminate the y's. So I'm going to multiply the top equation by 3 and the bottom equation by 5. And this is what we end up with. So we end up with 12x plus 15y is equal to negative 39. We end up with negative 30x minus 15y is equal to negative 15. So because of the way I multiplied it, again, I'm trying to get rid of the y terms. So I multiply the top equation by the 3 and the bottom equation by this 5 right here. And we end up again with this part. So what I do from this point on, let me change my pen. I'm gonna add the two equations going downward. So 12 plus negative 30, that's equal to negative 18. So negative 18x. This is gonna cancel out, and it's gonna equal to negative 54. We're gonna divide both sides by negative 18, and the value of x is going to be 3. So now that I know that x is equal to 3, I'm going to pick the top equation. So 4x plus 5y is equal to negative 13. I'm going to input and plug in this 3 into the x. So we now have 4 times 3 plus 5y is equal to negative 13. Well, 4 times 3 is 12. I'm going to subtract 12 from both sides, and 5y is going to equal to negative 25. So dividing by 5, we have that the value of y has to be negative 5. So the solution, let me do it in red. So your solution is going to be 3 and negative 5. So that's for the first one. For number 2, I'm going to eliminate the y's. Since the y's already have one that's positive and one's negative right there, I'm going to eliminate those instead. Okay, instead of eliminating the x's, I'm going to eliminate the y's. So I'm going to multiply, let me get the color blue. I'm going to multiply the top equation by 3. No, I'm sorry, not 3. That would eliminate the x's. I want to multiply the top equation by 4, by this number 4, and I will multiply the bottom equation by this 6, so that's 6. And both positive because, again, I already have them the opposite signs. I already have one positive, one negative. I just need them to be opposite numbers of each other. So this is what we end up with. Multiplying the top equation by 4, we end up with 8x minus 24y is equal to 8. And on the bottom, we end up with 18x plus 24y is equal to 24. I'm sorry, to 18. We add, and the y's again are the ones that get eliminated. So 8x plus 18x, that's equal to 26x. And 8 plus 18 is also equal to 26. So x is going to be 1. So what we do now, again, I'm going to pick the top equation. Using the top equation, I'm going to replace this x value with the number 1. So 2 times 1 minus 6y is equal to 2. So 2 times 1 is 2. I'm going to subtract that 2 from both sides. This is equal to 0. And then dividing by 6, well, 0 divided by 6 is still 0. So our solution for number 2 is 1, 0. For number 3, again, since the y values already have one positive and one negative, I'm going to eliminate the y's. So I'm going to multiply the top equation to eliminate the y's. I'm going to multiply by the other y value, each equation by the other y value. So I'm going to multiply the top equation by the 5. And the bottom equation is going to be multiplied with 4. This again is the easiest, the most guaranteed way of finding that common multiple. So here we end up with 15x plus 20y is equal to negative 10. And multiplying the bottom equation, we end up with 16x minus 20y is equal to, that's 72. 4 times 18 is 72. So now when I add, this is going to cancel out. We're going to end up with 131x and 62. So 31x is equal to 62. So that means that x has to be positive 2. Again, I'm going to pick the top equation. And I'm going to replace the x with the positive 2. So 3 plus 4y, 3 times 2 plus 4y is equal to negative 2. So multiplying these two, that's 6. We're going to subtract 6 from both sides. We're going to get negative 8. And we're going to divide both sides by 4. So y is going to be negative 2. So your solution is 2, negative 2. Now for number 4, I could eliminate either the x's or the y again like usual. This time we're going to eliminate the x's. Since the x's have already one negative and the other one is positive, I'm going to eliminate the x's just to change it a little bit. I could have done the same thing with the y. Since I have a positive and a negative sign on the two numbers, I could eliminate those also. Now it's really up to you. Most of you probably went with 3 and 4, eliminate the y since those numbers are smaller. But I'm going to eliminate the x's, okay? So again, you should still end up with the exact same answer, even if you eliminate the y's instead of the x's. So for the top one, if I want to eliminate the x's, the top one I would have to multiply by 5, and the bottom one would have to be multiplied by 6. And we end up with the following two equations. We end up with negative 30x plus 15y is equal to negative 30. We end up with positive 30x. When I multiply the bottom equation by 6, we end up with positive 30x minus 24y is equal to 12. So we're going to add, going downwards. This would eliminate like I wanted it to. 15 plus negative 24, that's equal to negative 9y. And 30 minus 12, that's equal to 18, negative 18. So the value of y has to be positive 2. Picking again the top equation, I'm going to replace the y with the number 2. So 2 goes there, and we have negative 6x plus 3 times 2 is equal to negative 6. So negative 6x plus 6 is equal to negative 6. We're going to subtract 6 from both sides, and negative 6x is equal to negative 12. Negative 6 minus 6 is negative 12. So when I divide, that means that x has to be 2. So here the solution is 2, 2. That's your value there. Now I'm going to skip numbers 5 and 6 since we did those in class. Okay, so the solution to those, if you remember from our notes, we actually did this in class, so we're going to skip those and let's just go to the back. So for number 7, here, since the problem is already set up and I already have a situation where I already have a positive and negative number right there, I'm going to eliminate that variable. So I'm going to eliminate the y's for number 7. To do that, I'm going to multiply the top equation by the 3 and the bottom equation by the 2, by the other number, okay? So multiplying those, we end up with the following system now. We end up now with 12x minus 6y is equal to 52, and 6x plus 6y is equal to 12. So we're going to end up eliminating the y's when I add downwards. This is 18x, and this is 64. So 64 divided by 18, that is equal to 3. 18 times 3 is 64. So now we're going to I'm sorry. Hold on. I made a mistake in my arithmetic. Let me fix that real quick. 3 times 14 is 42, not 52. So when I add 42 and 12, that's going to be 54. Okay, so I needed 54. And 54 divided by 18, that's equal to 3. So I am supposed to get 3. So there, let's fix that mistake and let's continue. So now we're going to use the top equation, and I'm going to replace the x value with 3. So 4 minus 2y, 4 times 3 minus 2y is equal to 14. So multiplying those two, that gives you 12. Now we're going to subtract that 12 from both sides, and we get negative 2y is equal to 2. And dividing, we end up with negative 1 as the value of y. So our solution for number 7 is 3 for the x and negative 1 for the y. So that's our solution. Let's move on to number 8. For number 8, yet again, since we already have that the y values already have different signs, one's positive, one's negative, so we're going to eliminate those. We're going to multiply the top equation by 3 and the bottom equation by 4. So we're going to end up with opposite numbers. 3 times the top equation multiplied by 3 gives us 15x, 12y, and negative, again, 42. We end up with 12x, multiplying the bottom equation by 4, we end up with 12x minus 12y is equal to 36. So adding downwards, we end up eliminating the y values. So this is 27x, and we end up with sorry, hold on. No. Negative 36. I'm sorry, I'm just having a little mental breakdown right now in the last two problems. Sorry about that. 3 times negative 12 is negative 36. I don't know what's going on right now. So we have now, then let's fix that again. So negative 36, and we add negative 36 with a positive 36. That also ends up eliminating, and we end up with 0 right there. Now we still have x's, so 27x is equal to 0. So we're going to end up dividing by 27. and the value of x is 0, okay? So we end up with 0 for the value of x. Now that should make the other part, next part is easy since we're gonna have 0, picking the top equation and plugging the number right here, the 0 right there. That means 5 times 0 is 0, so we could ignore that. So we're gonna simply end up with 4y is equal to negative 12. And when we divide, the value of y is negative 3. Now remember, we ignored this because that number is going to end up being 0. And adding 0 doesn't make much of a difference. Subtracting it to the other side is not going to change this number right here. This number is going to end up still staying as negative 12. So 4 dividing this number by 4, again, gives us that the y value is going to be negative 3. So the solution to this system is 0 and negative 3. I need to be a little bit more careful with my multiplication right there. Again, those little mistakes could cost me dearly in getting the right answer. So always double check again, like I was right now, that do double check the multiplication, okay? Now for number 9, since the x values have positive and negative and the y values have positive and negative also, it doesn't matter which one you eliminate really. But in this case, I'm going to still try to eliminate the y's. The y's have smaller numbers, 4 and 10. So I'm going to do that. I'm going to multiply the top equation by 4 and the bottom equation by 10. That way I can eliminate the y's. I don't want to use 25 and 10. So 25 times 4, that's going to be negative 100x, negative 40y, and 4 times 0, well, that's simple, that's 0. I'm going to multiply the bottom equation by 10, so that's 100x, positive 40y, and again 0. So when I add downwards, the y values got eliminated like I want them to, but also the x's, negative 100 plus 100, that's also equal to 0. So I have no x or y, so I just have a bunch of nothing on the left side, which is 0, and I add 0 and 0, which is again 0. So I have 0 is equal to 0. So the solution when we end up with this situation is infinitely many solutions. Sorry, it's going to write the wrong thing. So there's an infinite number of solutions. For number 10, since both again the x and the y's are already opposite, different signs, I could decide to eliminate either one of them. It's gonna have to worry about negative signs or anything like that. So you know what? Let's eliminate the x's. We've been eliminating the y's a couple of times on the last previous examples. Let's eliminate the x's this time. So here I'm going to multiply the top equation by 4, and I'll multiply the bottom equation by 3. I don't have to worry about using negatives because they're already opposites of each other. And we're going to end up with the following. So we're going to end up with 12x minus 16y is equal to 28. We're going to multiply the bottom equation by negative 12x plus 15y is equal to negative 30. Adding downwards, the x's, like I said, should eliminate, and we end up with negative 1y is equal to negative 2. So the value of y is positive 2. So again, I've been picking the top equation, so I'm going to keep doing that. I always love to pick the top equation when I substitute, but it honestly doesn't make much of a difference. I'm going to replace the y value with 2. So we have now 3x minus 4 times that y value of 2 is equal to 7. So 3x minus 8 is equal to 7. Adding 8s to both sides, we get that 3x is equal to 15. And dividing, we get that x is equal to 5. So 5, 2 is your solution. Now for number 11, uh, the variables are the same, have the same sign, so two negative signs, and over here we have two positive signs. So since they're not opposites, I'm gonna decide to eliminate the x's. Okay, so I'm gonna eliminate the x's. So I'm gonna multiply the top equation by 10, and I'm gonna multiply the bottom equation by 12, but negative. Since they're the same signs, I need one of them to be positive, and the only way I can get one to change to a positive is if I multiply it by a negative. Okay, so if I change the signs. So I'm going to multiply it by negative 12, so I can also not only get these two numbers to be the same, get this number and this number be the same, but also change the sign to that number and make it into a positive. So I'm going to multiply by the bottom equation by negative 12. So we're going to end up with negative 120x plus 120y is equal to negative 150. I'm going to multiply the bottom equation by negative 12. That's going to give me positive 120x, negative 120y, and positive 120. So when I add going downwards, the x values eliminated like I want them to. The y values happen to also eliminate like I wanted to. So we end up with simply 0 there. And negative 150 plus 120, that's equal to negative 30. And since we have zeros equal to negative 30, we know that that can't be true. So when we end up with this situation, the solution, we say that the solution is no solution, that there is no intersecting line. So these two lines end up having to be parallel to each other. Moving on to number 12. For number 12, let me pick a different color. The x values are already different signs. The y values have the same sign, so I'm going to eliminate the x's. So to do that, I'm going to multiply the top equation by 2 and the bottom equation by 3. Again, the other number. So 2 times 3, that's 6x plus 10y is equal to 30. Multiplying the bottom equation by 3, that's going to be negative 6x, positive 6y, and 18. Let me change colors. So I'm going to put black this time since I didn't write it differently. So adding downwards, these two things cancel each other out, and we end up with 16y is equal to 48. Dividing by 16, the value of y has to be 3. 16 times 3 is 48. Now using the top equation, let me change colors. Use this color. So 3x plus 5y is 15. I'm going to replace the y value, that number, with the number 3. So we have 3x plus 5 times the y value, 3, is equal to 15. Well, 5 times 3 is 15. Subtracting 15 from both sides, 3x is equal to 0. And dividing by 3, x is going to be 0. So the solution is 0, 3. For this example, again, very similar to something else that we've done. Nothing is different sign, so there's no real obvious choice here, okay? On the previous example, it was an obvious choice to eliminate the x's because they were already opposite signs. One was positive, one was negative. But on this one, since they're all the same sign, there is no obvious term we want to eliminate it. So I'm going to decide for this one. I don't know what you did on the assignment, but for this one, I'm going to decide to eliminate the x values, okay? So I'm going to multiply the top equation by 4, and I'm going to multiply the bottom equation by a negative 6. And again, let me explain why. Again, since these two are the same, I need one of them to be positive. So if I multiply by a negative, that automatically changes the sign. So multiplying by a positive 4 on the top is going to give me a negative 24x, a negative 16y, and a positive 8. Multiplying the bottom by a negative 6 gives me a positive 24x, a positive 18y, and a negative 18. But again, this is the key thing. Having a negative and a positive 4, when I add downwards, again, eliminates that term. So this becomes 0. Negative 16 plus 18, that's positive 2y. And 18 plus negative 18 plus 8, or 8 plus negative 18, that's equal to negative 10. Dividing by 2, then y has to be negative 5. Going to my usual equation, the top one, I'm going to replace the y value with negative 5. So negative 6x minus 4 times that negative 5 is equal to 2. So negative 6x plus 20 is equal to 2. We subtract 20 from both sides, and negative 6x is equal to negative 18. Dividing by negative 6, the value of x is going to be 3. And finally, for the last one, here I have the option, because the x and the y's, the x's already have different signs and the y's also have different signs. I could eliminate either one of them, all right? Again, no clear choice, but I'm going to decide to eliminate the x's. So I'm going to eliminate the x's. I would multiply the top by 5 and the bottom by, the top by 2, I'm sorry, by 2, and the bottom by 5. And since they're already opposite signs, one's positive and the other one is negative, I don't have to worry about multiplying by a negative, okay? Because if I multiply by a negative, that's going to switch the signs, and then I end up with two things with the same sign, okay? Either both negative or both positive, but I don't want that. I want one to be negative, and I want the other one to be positive. So multiplying the top equation by 2, we end up with negative 10x, negative 10y is equal to negative 10. Multiplying the bottom equation by 5, we end up with positive 10x, positive 30y, and negative 60. So we're going to add going downwards the x values like I want, like I had originally decided, it eliminated. Negative 10 plus 30, that's equal to positive 20y. Negative 10 plus, hold on, I did it again. I made a mental mistake. I did my math wrong. 5 times negative 14, that's negative 70. I'm sorry about that. Negative 70, not 60. So when I add those two numbers, that's going to give me negative 80. There, that makes more sense. Negative 80. And there, when we divide, we get that the value of y has to be negative 4, and that's some decimal. So negative 4. So going again to my usual equation, the top one, I'm going to replace the y value with negative 4 and negative 5x minus 5 times negative 4 is going to equal to negative 5. So negative 5x, negative 4 times negative 5, that's positive 20. We're going to subtract 20 from both sides, and negative 5x is going to equal to negative 25. dividing, we get that x is equal to positive 5. So this should be your answer. Now remember, on this particular problem, had you decided to eliminate the y's instead of the x's, you would first find that x is 5 and then that y is negative 4. And the same thing on the other one. Since I decided to get rid of the x's on number 13 and not the y's, had you decided to get rid of the y's, you would have found first that x was equal to positive 3, and then you would have found that y is equal to negative 5. Regardless, you should still end up with the exact same answers, regardless of which one you decide to eliminate first. Okay, so here would be your solutions for the other ones. Again, as usual, my disclaimer at the very end of this is that you should have hopefully had already done these and had tried these before watching this video, again, to check your answers. Now remember that Thursdays we have tutorials. Make sure that you attend, get some extra credit points to add to your quizzes and assignments. And like usual, I'm grateful that you watched, and hopefully this was very helpful. And seeing more examples and seeing these again explained was helpful and helped you understand better. Again, thank you for watching and have a good day.